All right, good morning, Tigers. This is our last lesson for Unit 5, our last quadratics lesson of the unit. So, yay! After this is LEAP review and stats. So, y'all are in the home stretch. Way to go. All right, so we are looking at systems of equations. I don't know if you remember systems of equations. The last time we did systems of equations, we would have two equations with an x and a y, and we had to figure out where they intersected. And we also used substitution and elimination to solve that. And we had to find a coordinate, so we had to find an x and a y coordinate. Okay, now we're getting into nonlinear systems. So instead of finding where two lines intersect, it could be a line and a quadratic, or a quadratic and an exponential. We have a couple of different options here. So, okay. So what I'm going to ask you to do is start on the spiral review. So just looking at the spiral review real quick, I've got some definitions here for you. Just to remember what kinds of functions are what. So linear equation contains no exponents. When graphed, it looks like a straight line. Quadratic has an x squared. When graphed, it's a parabola. Exponential equation has x as the exponent. When graphed, it looks like a J. Absolute value has absolute value bars. When graphed, it looks like a V. So what I'm going to ask is that I want you to try numbers 1 through 12. You are basically classifying as linear, quadratic, exponential, or absolute value, just A, B, C, or D in the blanks. Then, after 1 through 12, I need you to try 13 through 17. So 13 through 16 is just multiple choice, choosing which equation best represents that function. So knowing what kind of graph it is and where it has been shifted to will help you there. And then 17 is solving each system by substitution. And I don't know if you remember substitution, but basically what that means is we take maybe what y equals and plug it into y for the other equation. So here you're looking for an x and a y. Okay, so pause the video, give yourself a few minutes to do 1 through 17. Okay, I know that sounds like a lot, but it really, 1 through 12 will take you like 1 minute. The rest of it might take you a little more time. So go ahead, try 1 through 17. Okay, so let's look at, oops, wrong button, spiral review. Okay, so linear, anything that doesn't have an exponent or is shaped or graphs like a line. So that is everything marked with an A. So 2, 8, and 10 are linear. Quadratic is that parabola, that U shape, and anything that has an x squared. So we have 1, 9, and 7. All right, exponential has x as the exponent and has that J-shaped curve. So that would be anything marked with a C, so numbers 4, 6, and 11. Everything else is absolute value, that's D. It'll have the absolute value bars like 3 and 5, or graph of V like 12. Okay. All right. Then let's look at 13 through 16. So 13, this is V-shaped. So we know it's going to be absolute value. So it should have absolute value bars, which eliminates C and D. Then we're torn between a +5 and a -2. So if I look at my vertex, it's shifted down, which means I've had to subtract something. So we'll assume it was 2. That +5 would have pushed it up 5 units. All right, 14 is a parabola. So it's not going to have the absolute value bars. It's going to have a squared. Okay, let's look at the vertex. This has gone down 1 unit, so it's got to be C. I don't really know much about the width, so I can't really use that because this is kind of a quick graph. It's not a very, it doesn't have axes or like crosshairs, so it's kind of hard for, it's not gridded, so it's hard for me to tell about the width, but this is +6. This means it would shift up to where the vertex was up here. And we can tell that that didn't happen. We can tell it was shifted down 1, so it has to be C. 15, if this is a line, it's linear. So we know C and D are out because these are exponential. It has x as the exponent. So then we're torn between half of x plus 3 and x minus 2. Again, check to see where it's shifted. This has been pushed up to about 3 units, so it's going to be A. This would imply that it was shifted down 2 units. So our answer should be A. 16, it's J-shaped, so we're going to get rid of these two absolute value. We're torn between C and D. Normally, I don't know if you remember, exponential functions usually don't touch 0, and they cross at the 1 here, and they get infinitely closer to 0 and don't touch. So since this is crossing through 0, it had to have been pushed down 1. So this is getting close to -1 instead of getting close to 0. So that's why we're choosing this and not this +3 where it's been shifted up. All right, 17. Solve each system of linear equations by substitution, then check your answer. So I have my 2 answers. I figured this would be a good refresher for everybody. So I'm going to work this out in my black marker just because it's a little bit thinner. All right, so we have y equals x minus 13, and then I have 4x plus 2y equals 10. So what I'm going to do is I'm going to take what y equals and replace the y with that. What we don't want is to have a bunch of variables because we can only solve one at a time. So where that y is, I'm going to replace it with x minus 13. And then this equals 10. All right. So then I'm going to solve this. Now I don't have x and y, I just have x. So we're going to start simplifying. 4x. Then I'm going to distribute my 2. 2 times x is 2x. 2 times negative 13 is minus 26. And then this equals 10. I'm going to combine like terms, and that gives me 6x. I'm also going to add 26 to each side. So that's going to be 6x equals 36. I'm going to divide both sides by 6 to get that x equals 6. Now, where people mess up is they think they are done at this point, but we're not. Now that we have x, we have to get y. So I'm going to take x, I'm going to go back to the original problem, and I can plug it into either equation, either the top or the bottom. Now, personally, the top looks a lot easier, so I'll plug 6 in for x. I have y equals 6 minus 13, and 6 minus 13 is negative 7. So my x is 6, my y is negative 7. It does say to check your answer, which means we are going to take 6 and negative 7 and plug it into that second equation. We already have a 6 and a negative 7 in that top equation. That's how we got the negative 7. So we're going to just check it to make sure it works in the bottom equation as well. So we're going to plug 6 in for x, negative 7 in for y. 4 times 6 is 24. 2 times negative 7 is negative 14. 24 minus 14 is 10. So that is correct. Okay. So let's check part B, or let's solve part B. I have what y equals. I'm going to take that and then replace the y in the second equation. So we have negative x minus, instead of y, I'm going to do 4x minus 20, and then finish out the rest of this equation. That equals 5. All right, I'm going to distribute the negative. This is going to be negative x minus 4x plus 20 equals 5. Negative x minus 4x is negative 5x. I'm going to go ahead and subtract 20 from each side. So if negative 5x equals negative 15. Okay, I'm going to divide both sides by negative 5. X equals negative 3. So I have my x. Let's go plug it back in to solve for y. You can plug it into the top or the bottom. It doesn't matter. We did the top on this one. Let's do the bottom on this one just for fun. So we have negative x. X is negative 3 minus y equals 5. Negative 3 is positive 3. So I have 3 minus y equals 5. I'm going to subtract 3. Got negative y equals 2, which means y has to equal negative 2. Okay, so that gives me, wait. Did I do this wrong? I did something wrong. Oh, this is positive 3. That's why x should be positive 3. Okay, so this will be positive 3. Negative, all right, so this will be negative 3. We're going to add 3 to each side, which gives me 8, which gives me negative 8. Okay, sorry about that. This should be a positive 3. I plugged that in wrong. Okay. All right, so that matches my equation. All right, and then to check it, so we did just plug it into the bottom. Let's plug into the top. So y is negative 8. So we have negative 8 equals 4 times 3 minus 20. Negative 8 equals 4 times 3 is 12. 12 minus 20 is negative 8. So this does work if you do it correctly. All right, so that takes care of the spiral review. And let's go on to task 2. Okay. So task 2, Professor Hurst is, task 2 is writing functions and graphing nonlinear systems. So we're going to write 2 functions. One of them will not be linear, and then we will graph the system. All right, so Professor Hurst is studying different types of bacteria in order to determine new ways to prevent their population overgrowth. Each bacterium in the first culture that she examines divides to produce another bacterium once each minute. In the second culture, she observes that the number of bacteria increases by 10 bacteria each second. So here's the thing. We are doing 2 different times. We're doing minutes and seconds. So we need to have them in the same time. So 18, if the second culture increased by 10 bacteria each second, what is it increasing by each minute? Okay, so we have 10, we're increasing 10 per second. Okay. There are how many seconds in a minute? There are 60 seconds per minute. So how many bacteria per minute? Well, if it's 10 per second for 60 seconds, we're going to multiply these. That is 600 bacteria, or bacterium, because that's one. No, I'm sorry, that would be bacteria. So 600 bacteria per minute. All right. So number 19, Each population began with 10 bacteria. Complete the table for the population of each bacteria sample. So what I would do is, for my elapsed time, I'd start with 0 and maybe just go up to 4 minutes. You could do different minutes. But remember, population of sample A, it is dividing. So remember, we started with 10 bacteria in each. So if each piece of bacteria splits into 2, after 1 minute, we should have 20 bacteria. In population B, we're adding 600 per minute. So that would be 610. So we're doubling here. We're adding 600 here. Okay? So I'm going to ask that you finish the table for 19 and then answer numbers 20 through 24. So you're going to do 19 through 24. You're going to finish out the page for me. And then you can check your work against mine here in a minute. So pause the video, get some work done, and we'll check it in a minute. Okay, so let's look at what we've got so far. So for my tables, I doubled population A, I added 600 each time on population B. So population A, it asks us to describe what type of function for each population. So since I'm doubling, I have a common ratio or a growth factor of 2. So to get from 1 minute to the next, I'm multiplying by 2, which would be an exponential function. Population B, to get from between each minute, I'm adding 600 bacteria, which means I'm adding a constant rate of change or a common difference, or my slope, I have a common difference or a slope of 600, which makes that linear. 21, write a function A of t to model the number of bacteria present in sample A after t minutes. So I don't know if you remember writing exponential functions, but we always have our initial value, our growth factor, or our common ratio, and then we have our exponent, or our input. Okay, so then 22 says evaluate the function using 2 input-output pairs from the table. I did 3, but to show that your function is accurate. So we're just evaluating, making sure that when we plug these numbers in, we get the same thing that we got in our table. 2 to the 0, anything to the 0th power is 1. 1 times 10 is 10. 2 to the 2, 2 squared is 4. 4 times 10 is 40. 2 to the 4 would be 16. 16 times 10 is 160. If I look at 0, 2, and 4, should have 10, 40, and 160. All right, 23, same thing, but we're doing it for sample B. This is a y equals mx plus b. We have our slope, or our common difference, and we have our y-intercept, or our initial value, what we started with. All right, so we plugged in the same numbers, 0, 2, and 4. 0 times 600 is 0, plus 10 is 10. 600 times 2 is 1200, plus 10 is 1210. 600 times 4 is 2400, plus 10 is 2410. If I check my table, I should have at 0, 2, and 4, I should have 10, 12, 10, and 24, 10. So 10, 12, 10, 24, 10. So so all of my answers, or all of my functions, match up with my table, which is what I wanted. Alrighty, so let's move on to number 25. And we're going to graph this in Desmos. So should have Desmos pulled up. We can, I'm having a brain fart. Or you can use a graphing calculator and just make a table or whatnot, but we're going to pull up Desmos. And what we're going to do is we're going to come over to here. And let's do A of t. Let's type in our two functions. A of t equals 10 times, if you need times, you can hit Shift 8 and it does the little dot for you. 2, Shift 6 to get the exponent, and we'll do t. And that way our variables match what we did on our problem, or what we did on the packet. Okay, let's also do b of t equals 10 plus 600t. All right, so we're looking at this. This is not very helpful to look at. So, yeah, that's not pretty at all. Let's see, but what we can do, let's make a table real quick. We're going to change x1 to t. We're going to change y1 to a of t. And then we're going to add another column and do b of t. Okay? Let's see. Let's plug in some numbers. Let's plug in, oh. Let's see. Okay, well that didn't work. All right. Let's gonna see if we could get some x and y values. That's okay. All right. So I'm gonna do this a little out of order from what it tells us to do. So it wants us to sketch the graph, but we can't see anything. So let's look at C. Or actually, let's not look at C yet. Let's make our graph match this. So let's do from 0 to 10 on the x and 0 to 10,000 on the y. And actually, I like to give myself some breathing room, so let's do negative 1 to 10 on the x and negative 100 to 10,000 on the y. And that just gives us a little more to look at. All right, so let's graph. We do need some points, so we have points at 0, 10. Let's do A of t first. So that was what I did in pink, I think, earlier. So let's do our A of t first. So we have some points at 0, 10. Oh, I know what we can do. Let's change this A of t to y1 and x. Change this to y2. We'll change this to x as well, and then we'll make our table. That'll make things a little easier. So this is just x. This is y1. This is y2. And we can go 0, 1, and you see the numbers automatically pop up for us. So we'll go all the way to 10. And now we have some numbers that we can graph. All right. Okay, so there we go. That makes things a little bit easier. All right, so A of t. Let's see, what can we graph? We can graph 0, 10, which is going to be kind of hard. Let's see. We can do, let's do 5 and 320. Let's do 7 and 1280. And let's do 9 and 5, 120. Okay, so these numbers came from here. I'm trying to pick some numbers that would be that would help us sketch this. So 0, 10 is going to be like almost on 0, 0 because this is 500. So it's basically going to be 0, 0. When we get to 5, we're at 320. This is 1,000. So 320 is going to be less than halfway up. At 7, we've got 1280. So it's going to be a little bit over the 1,000. Then at 9, we've got 51 or 5,120, which is going to be just above this line here. At 10, we're over 10,000. And we could fill in some more, but this should be enough to kind of get us started. And that's going to be pretty much as good as it's going to get. Let's look at B of T. We're going to do the same thing. We're going to start with 0, 10. Let's do 3, 18, 10. Let's do 7, 42, 10. And let's do 10, 60, 10. Okay, so 0, 10, we have a point. At 3, we have a point at 18, 10, so that's going to be a little bit below the 2,000. At 7, we have one at 42, 10, so it's a little above the 4,000. And at 10, we have at 60, almost right on that 60,000. Okay, and that should be a straight line there. Okay. All right, so let's zoom back in on this so we can see. So we've graphed our 2 bacteria colonies. All right, part B says label the independent and dependent axis on the graph on the right. So X, what does X represent? That is our elapsed time, T, and that is in minutes. This side, our Y, that's our A of T and our B of T, that is the amount of bacteria, or the population of the bacteria cultures. So we'll put bacteria population. Okay, so we have our minutes and our bacteria population. All right, part C, we're going to change our domain and range so that we can see everything. And then we'll determine our points of intersection. So, asks us to change our domain from -3 to 12. So let's see what happens when we do that. So if I change this from -3 to 12, and it also says with a step of 0.01, and that should change our, oh well, it's not doing that though, oh well. And then our range, we're gonna go from -1,000 to 6,000. So we're not gonna look at the top of the graph, just kind of right here. All right. Oh, and it did say with a step of 20. Does that do anything? No. Used to. Okay. All right, so we did change our stuff. D says determine the points of intersection of the two functions. So there are 2 intersections here. So remember at the beginning, I told you that when we solve systems, we're looking for the one, when we did linear, you would have either 1 point of intersection, or the 2 lines would have no solution, they wouldn't intersect at all, or they would be 2 of the same line on top of each other and you'd have infinite solutions. When we have nonlinear, we can have multiple solutions depending on the type of function. So we're looking for 2 points of intersection. So if I look, I should have one here at 0, 10. And I should have one here at 9.095 5466. All right, so I've got 2 points of intersection. So we have 0, 10, and it says round to the nearest tenth. So move this over a little. 9.09, that would round to 9.1. And this would round to 5,466.71 would round to 7. Okay. 26. Explain what the intersection points of the functions represent within the context of the problem. So we have an intersection at 0, 10. If we look, that would be here on my graph, or right here. And if we remember, we started off with the same amount of bacteria. So at 0, 10, both populations began with 10 bacteria. Okay, well, what about the other intersection point right here, that 9.1? So this is another point they have in common. So that is 9.1, 5466.7. That means both there's no S there. Both populations had 5466.7. Now, you're either going to have a bacteria or not, so it's not perfect, but that's where they would both have either 566 or 5466 or 5467, just kind of, but had the same number of bacteria at the same time. So this would be after 9.1 minutes have passed. So that's the same time and number of bacteria. All right, 27. Fully explain which bacteria population contains more bacteria. So this is kind of difficult because it has two different answers. So for the first couple of minutes, our blue line is greater than our pink line, or our pink curve. Our blue line is greater. So we could say until this 9.1 minutes, population B has more bacteria. But after those 9 minutes pass, population A overtakes it and has way more bacteria. So let's say for about the first 9 minutes, or we can say 9-ish minutes, oops, not both I'm sorry, I'm reading the above question and not thinking. Population B has more bacteria. Population A catches up and surpasses population B. After 9 minutes, and will continue to outgrow B. Okay. All right, so for the first 9-ish minutes, population B has more bacteria. Population A catches up and surpasses population B after 9 minutes, and then it will continue to outgrow B. Okay. Let's look at the next page. So this is where we're trying to get to. We are solving nonlinear systems. So we did kind of solve a nonlinear system with graphing right here. We found the 2 times that those 2 populations will have the same amount of bacteria. Here we don't even have context. We are just solving linear systems, or I'm sorry, nonlinear systems. We can't, so the first thing we want to do is we're going to solve, number 28, we're going to solve with graphing. Number 29, it does say you can use substitution or elimination. I actually would not recommend using elimination. Just because you're going to have some squareds, you could have some exponents. It's not, we'll use substitution. Okay, so I'm going to do C, and then I'm going to let you try A and B on your own. So 28 says, use the Desmos graphing calculator to solve each system by graphing. Use the tables provided and use 5 ordered pairs from the functions to sketch them on the provided graph. So what I'm going to do is actually, let's change this to, we're going to change this. We're going to delete some of this. We're going to pick, let's do, I don't know, -3, -2, -1, 0, 1, and 2, and 3. Okay, but we're also, let me get home, going to change these to our 2 functions. So, change that, and change that. So what I'm doing is I'm kind of cheating and giving you some ordered pairs to plug in. What you could do is you could pick ordered pairs, plug them in, and graph them. But you don't have to do that. So our first equation, we have y equals 2 times 5 to the x. So we're going to do 2 times 5 raised to the x. And we've got some points we can graph. And let me change my wrench to go from -6 to +6, -6, +6. That way we can kind of see everything. All right, for y2, for our second one, we're going to do -x squared plus 2x minus 2. Okay. So we've got some points that we can choose to graph by hand. So let's do this one in blue. Let's do -2, -1, 0, 1, 2. That would give me, I'm just copying from Desmos, 0.08, 0.4, 2, 10, and 50. So when I go to graph this, we have a point at 0.2, point at 110, that's going to be off the graph. Let's see. At -1.4, that would be a little bit below halfway. At 2, that would be getting close to 0. So we're going to get, that's about as good as we're going to get. Ooh, that's ugly. Okay. Then we're going to do the second one in pink. So I'm going to copy values from over here. I'm probably going to pick the same numbers. So we'll go from -2, -1, 0, 1, 2. Gives me -10, -5, -2, -1, and -5 again. Oh, wait, that's too much graph. -1, -5, 0, -2, 1, -1. Whoops, that should be 2, -2. And then 3, -5. Okay. All right, so let's look at this. So I've got two functions graphed, and I'm looking for their point of intersection. Well, what do you notice? This is never going to go past 0. This is going to keep going up. These are both going to go down. This is never going to go above 0. There is no solution. The way these graphs are going, they are never going to intersect. So this one has no solution. They do not intersect. Okay. All right. So I'm going to ask that you try A and B on your own. I'm not going to do the answers for you. They will be on the key, but you will do A and B on your own. And you can check the answers with the key. Okay? I will tell you one of them does not have a solution and the other one does. Okay? So there's another one that does not have a solution. Okay. Last task. Task 4. We're going to solve with algebra. Okay, so give me just a second. Let me pause something and check something out real quick. All right, so I had to double check something, make sure I did this one correctly, because I was actually going to assign one, and now I'm looking at it, I'm like, that would not be a good one to assign. So I'm going to work C, and then I'm going to let you try A and B on your own. C is very, very nasty, so I don't want you working that one by yourself. So we're going to solve using substitution. So basically, I'm going to take what y equals and plug it in for y. And that gives me negative x plus 3 equals x squared minus 2x minus 4. Okay, so now we don't have any y's, we just have x's. This is an x squared, so we're going to have to solve, it's a quadratic, so we're going to have to use one of our solving quadratics methods. So I'm going to add x and subtract 3 from both sides. What that's going to do is that's going to get this equal to 0, and then I can pick a solving method. So we're going to have 0 equals x squared minus x minus 7. All right, from here, what we're going to do is you can pick a method. I will tell you, obviously it says solve with algebra, so graphing is out. Also, when you graph it, this is going to be ugly. You're not going to be able to get an exact answer, so graphing is out there anyway. Factoring, we cannot do. That's not going to factor. Square roots isn't going to work because we have an x without a square. So our options are complete the square and quadratic formula. Now, I will tell you, I tried completing the square and got frustrated. So let's go ahead and do quadratic formula. So quadratic formula, x equals negative b. So we have negative, our b value is -1, plus or minus the square root of b squared. So that's going to be, again, -1 squared minus 4 times a times c. Okay, my a value is 1, my c is -7. And this is all over 2 times a. And a is 1. Okay, so we're going to start simplifying. X equals negative 1 is positive 1. Plus or minus the square root of, okay, negative 1 squared is 1. Negative 4 times 1 is negative 4. Negative 4 times negative 7 is 29. So this is 28. 1 plus 28 over 2. Okay. X equals 1 plus or minus the square root of 29 over 2. That's it. That's not very pretty, but those are my two X values. That won't simplify any further. Okay. So I wish I could say I was done, but we're looking for ordered pairs. So we're looking for X and Y. And when we do this, we have to plug in both of our X values and get our Y values. So remember, we have two X values, 1 plus square root 29 over 2, and 1 minus square root 29 over 2. And we're going to take those two X values and plug them in. Now, I would plug into that top. I would not plug that crap into the bottom. That looks like a pain in the butt. So, we're going to plug in. We have Y equals negative our X value. So, 1 plus square root 29 over 2 plus 3. And Y equals negative 1 minus square root 29 over 2 plus 3. Okay, so at this point, I, honest to goodness, would make this a fraction, or not a fraction, a decimal. I would, honest to goodness, make these decimals. So I would put this in the calculator, get decimal, put this in the calculator, get decimal, put this in the calculator, get decimal, put that in the calculator, get decimal. So let me do that real quick. Okay. All right, so we're going to do 1 plus square root 29, got a decimal, divided by 2. All right, so my X here, let's see, trying to make some room here. So I've got two ordered pairs. My first X is 3.19. All right, we plug that in here. We made that negative, so we're going to do negative answer. Oops, sorry, I could have lowered that so y'all could see what I'm doing. Negative this, and then we're going to do plus 3. We got negative 0.19. Okay, so there's our first ordered pair. Our second ordered pair, we're going to do 1 minus square root 29 divided by 2. Our second X value is negative 2.19. Okay, then we're going to, over here, make it negative, negative answer, plus 3. That gives us 5.19. So it gives us two ordered pairs. Can you tell why I didn't want you to do this one on your own? That is ugly. All right, so then it asks us to use Desmos to check our answers. So I went ahead and graphed. We have negative x plus 3, x squared minus 2x minus 4. So let's look at our points of intersection. Negative 2.19 and 5.193, which is what we have right here. And then 3.19 and negative 0.193, which is what we have right here. All right. So that was kind of an unfair one for y'all. So let me look. I still want you guys to do these two on your own. But let me look up one more and I'll give you another problem to do on the back. So let me pause my video. I'm going to find another problem and then we'll do one more. Okay, so found another one for me to show you that is a little less scary and still gives you two practice problems. So, all right, we've got two. We're going to solve by substitution. We're going to take this negative 2x plus 3, plug it in for y. Or you could take this and plug it into this y. It's the same thing. So anyway, we end up with negative 2x plus 3 equals this, x squared plus x minus 1. Okay. So then we're going to get everything equal to 0. So we're going to add 2x and subtract 3 from each side. And this gives me 0 equals x squared plus 3x minus 4. All right, so this is a regular old quadratic equation. You can solve by doing, let's see, we're not graphing. You could factor this. You could complete the square, or you could do quadratic formula. So why don't we factor this? This would be an easy one to factor. I need two numbers that multiply to give me negative 4, but when I add them, I get 3. And we could do positive 4 and negative 1. All right, so there we go. So that's pretty simple to solve. All right, so 0 equals x plus 4. 0 equals x minus 1. Subtract 4. Add 1. Now I've got x equals negative 4 and x equals 1. So I have two x values. I'm not finished though. Even though I have my x values, I need to get my y values. So I'm going to take both of these. You can plug those into the top equation. I would just plug them in the bottom. Okay, so I've got y equals negative 2, but instead of x, I'm plugging in negative 4. And then plus 3. And then I also have y equals negative 2. Instead of x, I'm going to plug in 1. And then plus 3. Okay. So here, y equals negative 2 times negative 4 is positive 8, and 8 plus 3 is 11. Over here, negative 2 times 1 is negative 2. Negative 2 plus 3 is 1. So this will be y equals 1. So I have two ordered pair solutions. Negative 4, 11, and 1, 1. All right. Much easier than the last one. Aren't you glad I did the last one with you? So it could range from super, super difficult to super not so bad. Let's look at the graph and double check that these are okay. So we're going to graph the first two equations. So we have negative 2x plus 3. So let's do that here. Negative 2x plus 3. And then we also have x squared plus x minus 1. So x squared plus x minus 1. We have, oh, that has a 2. That's why. Get rid of that. There we go. We have a point at 1, 1. Scroll up. We have a point at negative 4, 11. Okay. All right. So what I need you guys to do for the rest of class, go back to task 3 and 4. I need you to graph A and B on your own and solve, and try A and B with algebra on your own and solve. So good luck. Thank you so much for paying attention. Hope you guys have a great day. Thanks.